Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Hello, everyone. So the thing is that everyone is talking about artificial intelligence. Everyone is talking about ChatGPT. And sometimes ago, this ChatGPT and OpenAI project was very much hyped in the market. But after some time, the Europe is right now ready to implement artificial intelligence somehow in the industrial level, which means that many automotive sector, many other major players are trying to implement their own kind of sometime LLM, which means that they want to build their own ChatGPT. Sometime they want to build something very similar, but getting the API from the API from the OpenAI. Well, great. Today we are going to see some challenges or new trends in the world of LLM because this is a really very important topic right now, and this is getting very hot as well in the marketing industry and whole Europe and I would say that whole world is trying to increase, increment, enrich, and make better the processes with the help of AI. So for that, I come up with the idea to discuss some challenges and some new trends in the LLM and this GPT board. So we'll discuss in total very important 3 to 4 out of these challenges, but the number one challenge or number one trend right now is that the architecture of any LLM model should be highly modular. Well, great. They said that architecture should be modular. No, the thing is that what is mean by the modular architecture? What does it mean? How that works? What are the methods? What are the tools? What are the libraries? What are the technologies? Which coding language is very important. So these things are very important. Let me just guide you through what is the modular stuff. So to get the in-depth understanding of modular is nothing but the modular model says that you cannot train one single model based on a big text corpus and try to get response out of model. Why? Because the reason is that when you train a big model, the adjustment in that model are very, very difficult. What does it mean by adjustment? For example, you want to retrain something or you want to improve the accuracy of something or some domain is getting, wrong. What you will do? You will retrain the model or fine tune the model, but fine tuning is, very hard. Where from they have taken this concept of modularity? This concept is really taken by the concept of Google, how Google actually separate its monolithic style of application into the small chunk and pieces of the application, and that is called microservices. There are two kinds of architecture of any services. So if I could draw it, so the two kind of architecture is one is monolithic. What does monolithic mean? I have a big container here or big computer, and I have all the piece of my applications are running inside. So this is the really the example of monolithic applications, and the other one is the other one is that, for example, not monolithic, rather it is microservices, which means that part A of application is here, part B is here, and part C is here. So this is part one, this is part two of application, and this is part three of application, which essentially means that there are self-contained application, and now you can join them together at central space and work like that. So this is very efficient. For example, in the over the passage of time, you need to replace this one. What you do, You just come here, you replace some stuff here, and these two are still working, no problem. And then you can replace it. And when it's replaced, the new one is working. But here, if you want to do something, for example, this is part one to part n, and everything is back in the one, and you just need to stop everything and rebuild again. So this is monolithic, and this is the problem of monolithic architecture. So by the modularity of large language model, we always mean that we are actually creating the different small models, and these small models are somehow trained on the domain specific knowledge. Let me just take you example. For example, you want to build your own customer support artificial intelligence based chatbot, which is highly context and knowledge oriented, and which take the context of knowledge and which reply the customer very similar to human beings. So this is our example of chatbot for customer support SU, customer SU support chatbot. Chatbot. What that chatbot does, any customer of you is coming up with any query. What does it do? It is trying to solve your problem. What does it do? It's trying to solve your problem with help of very relevant information already available in the market, in the organization, and this model has been trained on that. So let me just tell you how you can achieve this effect with the help of modularity. So, for example, what you do, you just uh, you just create a 5 or 4 model. You get AI pre-trained model. After this video, shortly, I will get into how you actually train embeddings in some concept which are actually behind, and I will again connect them. But I will start from the very basic, from the very beginning, how actually you convert text into the token and token convert into the embeddings and how this process works. But let me just first build a ground of the LLM problems, that what are the LLM problems, and one of which is the modularity and how you achieve the modularity. And this is very trending right now in the market. Okay, back to our example of customer support chatbot. I want to generate or train or fine tune a small model with the help of document. For example, I asked my team, okay, please can you everybody just search the whole document base and whole log of the customer support for the last 10 years, and please give us the categorization of the documentation. Like just create a separate folder and please give me a different folder. And in every folder you have, for example, here you have one folder of troubleshooting, one folder you have of for example, return processing, for example, any processing about the return of the goods, and so any other thing. For example, my question is regarding the software or something like so, like this. So here I have FAQs. Here I have FAQs. If the request is about FAQ, this is my model space where I train small model and put it here. My second model is regarding to the troubleshooting, for example, how to reset password, TB. Let's call this troubleshooting, and for example, troubleshooting means that how to reset password, how to install this app, or something like that, something like that. For example, all the questions related to this, how I can do that, how I can reset my password, how I can install this app, how can I access Wi-Fi. So these are the troubleshooting problems. I categorize them and I put them in another box, which is this. Then I come up with the idea that, well, there is some return processes. And by return processes, I mean that return of the goods. whatever is purchased, customer want to return them because it is defected. The goods are defected. I am not happy with performance or whatever the cause could be, right? And then let's say like that, some queries are general purpose queries. You cannot categorize them because it is about the overall system. You can say that shipment, overall performance, overall quality process, time of request handling, or whatever. So now what I do, now I create small bins. In each bin, I train a model. Relevant customer queues, question and answer session. Whatever simple question and answer asked, come up here. Troubleshooting problems, all the documents, all the, for example, I have 3000 document of troubleshooting. All that information comes here and I train a model on it and I train a, GPT model on it and I place that model here. So then I have this, for example, I call it, let me just write it to return, 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 and then general general purpose. So this is overall the scenario of my app right now, and these all are nothing but they are nothing but they are AI models. There are AI LLM models. They are LLM models, right? These are all the LLM models, and now what I do is that rather than putting them architecture wise in the one whole big box, I have separated each model. And now, for example, my customer, my user says here that here's my user sitting here. He says that how to reset the password. Now my system here comes and think, okay, it first search all the documents here. For example, I have 10,000 documents here. Based on RAG model, now I will shortly discuss what are the RAG models and how they work really. This is a very important concept too, how the RAGs work. I have here RAG and then I have NLP process. I will get through this process because this is very important. But for example, it gives this query to the RAG and RAG try to search this 10,000 10K document and come up with three article as a context of knowledge, three article as a context of knowledge plus query, plus QUERY, plus query. Then this whole stuff is giving query and plus categorization, and it categorizes it as a TB. It categorizes that this is TB problem. What does it do? So, for example, it is TB problem. Automatically, out of four model, it's going to select TB, and then what it do? It do some evaluation, eval, confidence score, eval, confidence score, C score, to evaluate that how good this response is. For example, if response is very good, and then it's return to the user. So this is the query. Then it asks user, okay, how satisfied you are with the response, and it is the feedback loop. This is a feedback loop. Feedback loop says that okay, for example, this is, sorry for the bad drawing. For example, we say this is the thumbs up. And if the customer says, okay, I'm happy with the response, great. If customers say I'm not happy with the response, then right now it's not going through the whole concept again. It's get that out here, inject here to the system again, And this time it's bypass and say that maybe it's problem of FAQs because the answer was not satisfactory. And this process is looped through all the models when it is required until customer is satisfied. So this loop is going to do in the feedback fashion. So that's how actually document retrieval augmentation works, and that's how it's do. This is the overall picture of the modular LLM. And by modular LLM, this is, for example, Docker container. This is again dev concept. Your Docker container number one, your container two, container three, and these containers with help of network router are connected to each other, and then your application is running here beautifully, and your model responses sometime. It is export of model that is called export of model approach. This is export of model approach. And now these systems are on the domain specific. By domain specific, I means that they are trained on specific context or the specific domain. That's why it is kind of very important that on which concept they are really, trained. And this is kind of also very important here. Great, that is that. But you may ask question that what is RAG? How does RAG work? It is how it's increased the process, what role it does play. So you might have many questions about RAG. We are saying that with help of this RAG process of document retrieval augmentation, we can supplement over query. We can make our query more relevant and context oriented, so that our model doesn't do hallucinations. What does we mean by hallucination? That sometimes there are very general general purpose queries. For example, if I give this query to ChatGPT, how I reset my password, ChatGPT would say, okay, there are many different ways to reset a password, but it depends which kind of password you want to reset. Either it is window, or either it's Ubuntu, either you are resetting the password of iPhone, either you are resetting the password of Google Cloud or whatever. So then this question cannot be answered by the AI. This is very difficult for them. But when I say this, how to reset password to my RAG system, and RAG system does know that it find like 5 articles already written in the documentation of the company that how to reset the password, and it's get the vectorization and vector similarity of those dense space of the vectors along with, and then it's applied to the system which is already trained on the specific troubleshooting task. Then the then the language generation model like LLM or ChatGPT come up with the very accurate response, and the error of response is less possible. Why? Because right now it has a lot of context with it, and this context actually make it clear that how you think about which direction customer or your user is talking about, which direction, how you think about the problem. Might be he's not explaining the problem very well, but that's what he meant. And yeah, these are the rack system, very beautiful system nowadays in the market. But before we go into the detail of RAG, we need to understand how AI works, how AI really knows that which word and how it generate the responses. This is very important. In the next step, we need to go to the AI, that how AI really do this stuff and how the AI is built from the very basic. I will give you some example. For example, let's say like that. What happened is in the 10 years ago, not days, 10 years ago or 15 years ago, people were trying to learn different NLP techniques, that how they can understand the language or how computer can understand the language. Well, for computer understanding language is very difficult because if I am sitting here and I'm saying that, okay, it is very hard to sit here. Then as a human being, you easily know that it means that this room, it is means that this room is sitting in this room is very difficult. But for a computer, what you refers to it is very difficult to understand. That's why it need to somehow some mechanism. The early linguistic come up with the idea that you convert your all the text into the embeddings. Now question arises, what does this embedding means? The embedding means that, for example, this is the sentence. For example, this is the sentence, the cat sat on the mat, right? This is raw text. What I would do, I would, for example, get all the word embeddings and convert them into matrices in the mathematical matrices 0.001, 0.002, and 0.7. And this matrices means cat. This matrix means cat. And there are just initial number. I just convert my cat cat into some with some method. Those method I'm not going to discuss because they are kind of complex and require another tutorial. But the words get converted into the numerical matrices rate with some dimension. For example, 300 dimension or whatever the length of this line is. And these word then has been trained. How they are trained? For example, I have whole bunch of language of English. In English language, for example, I have collected text from the everywhere, from the internet, from the books, from the novels, from the I don't know where. I have collected all the text, converted into some initial numbers. This number doesn't make any sense. Zero point 0.2, zero point 0.4, zero point 0.5, and these numbers is get set on the set. And these number doesn't make any sense. These are number which are completely irrelevant. Now, what initial system of this AI does, this initial system is actually converting them into the vector space. What is the vector space? It is just mathematical ways to, you know, uh, mathematical skip gram model or COBO, continuous pack of word methods, trying to predict that, okay, if there is a word cat, I have word cat. What could be the next word actually? And next, and next in the three sequence. And this is called the window. Window you want to predict the word. That's how the language generation works. That what do you think that and they start training themselves with different in the early stage. So the people actually also label some words and they also try to predict these words and adjust these words. And over the passage of times, actually, they start this initial waiting something different, change some other. Over the passage of time, when cat and sat they are very near, these word embeddings start changing. For example, they are start getting to very closer. For example, they are start getting to very closer in the way that this is 0.25 and this is 0.29. Now they are very similar, and this whole number as well very similar, and which means that cat and sat, these words are cat and dog. These words are normally appear very much near to each other because in the history of this corpus of 7 billion text token, they are normally appear together. So initially these model, for example, word to vector, globe, and fast text, these models start to train them in the way that which word should comes near to other word. That was the overall semantic context meaning based vector enhancement. I have 7 billion vectors, completely random, don't know that which word should be closer to each other. Then these model in the start very, very beautiful, intelligent people sit together, they develop some mechanism, they research on NLP, and they come up with the idea that, well, we have some model which can actually continuously improve the embeddings. What does it mean by the improving the embeddings? That changing this vector first, the value of this vector, and pushing all relevant work together. For example, you can imagine that we have this bag of word. We have 7 billion uh, words randomly thrown into the bag or thrown somewhere. Now our task is to, for example, mm, there are small piece of paper on which some word is written, and I am giving you the job that okay, you sit here, you throw them on the floor, all these small words, and with your understanding, try to get these words who are normally appear together or they are similar in the sentence most of the time based on any criteria. Let's say I give them some criteria and you push all the words closer together. And for example, it says that cat and dog normally appear very near, and they push them together. For example, similarly, they just randomly uh, get that label of the word, a piece of paper, and they just move those piece of paper together. And let's say like that, it is the city of words. And in the end, you have moved many words together. Now it is good context. Why? Because language is something that is very logical. And some word and some verbs, some part of speech of the grammars, they really push them together to make sense. And this is what learning of the model is. And we called we call the trained embeddings, the trained word embeddings. These trained word embeddings is very important for any document retrieval system, let's say like that for the RAG. Now you understood how this model come into the birth, how from the very start this word embedding comes, and after these word embeddings, many model are trained and many techniques come out. For example, Google come up with the machine translation model, which is GPT like pre-train GPT like generative pre-trained models. And on top, then many the OpenAI borrow those models from there and they build something on top. So then over the passage of time, we have a lot of stuff which is already available in the market. A lot of libraries in the Python are written. You don't have to reinvent the wheel. You don't have to do the basic research from your own. There are many resources already available. PyTorch libraries, TensorFlow libraries, Keras libraries, the document retrieval augmented libraries, for example, from the Facebook like FASSS, or there are like five or six basic libraries that can do very beautiful stuff in the RAG. Mm. Now let's see how you can input, and even now you can train your model based on the RAG output as well. How? As the same example, you say how to reset my password. You say this, then your tokenization or basic NLP filter this word out. It's it's and convert words in the embedding based on the pre-trained weddings, like it gets the weights very relevant to each other, and then it supply or match this vector, this whole vector with the organizational knowledge, for example, documentation or previously asked question or whatever could it be, like it query embedding and your retrieve document. It's compare, and then it come with the top three articles we have discussed here in top. In in this year, we have discussed that it comes up with the three top ideas. Where is that? Yeah, it come up with this three top article. So it comes up with three top article here, and these three articles are most similar document available in the document database. That's how the contextualization really works. And along with the query, then it's applied to the system and says to the generation model, which is something totally different. RAG model, something different. RAG model, the task of the RAG model is to get the most relevant information available in the organization document. gel them together, combine them together, pack them together, supply to the generation model, which could be OpenAI, ChatGPT, could be any LLM, private one, any Olam or whatever, Facebook, Mistral or whatever it is. And then it's trying to give you a response because now this response is very educated response. This response knows that what customer want to ask. And this is how the generating output works. Now your question would be that what are some libraries or what are some methods with which I can really get the retrieval system and how I can do the feedback process. I have already explained this in very much detail that what you can do is that there are a lot of NLP, there are some libraries I have written here which you can really use. Yeah, here are the libraries. So there are some framework or the libraries already available for the RAG. The big one is the Hugging Face. You go to the Hugging Face, you get multiple different word embeddings, RAG trained model, already trained RAG model. You get the pre-trained RAG models here. You get you load them, and then you supply them your query, or you can also hook your personal or your custom built a generative model or GPT model, whatever it is. You can supply or convert your whole knowledge base of your organization and provide it. So it's in the end generate you the whole model. So there are multiple libraries. For example, Hugging Face is option number one. FAISS is Facebook. This is open source and also so very good model, created very dense vector space similarities along with. And then there's a Haystack deep set. Haystack deep set is the beauty of this RAG model is that you can integrate some other features like Elasticsearch and NLP pipeline, Hugging Face pipelines, Transformer pipelines, ChatGPT pipeline. It is very similar to LangChain. It is very similar to LangChain. It is very similar to LangChain. It's working very great. So you integrate your setup with this, and this is also a very famous one, this Haystack Deepset, because due to the integratability. And with all this supporting tool, you can create a dense passage retrieval. Dense passage retrieval indexing mechanism where those document really lives, and with the help of that, you can create a RAG-based system. And in the end of the day, you can create this modularity. The problem number one we have discussed, add the modularity in the architecture of the large language model. That's how this whole pipeline works conceptually. But of course, practically, you need to know about different Python programming language, how some libraries work together, how you can use NLP. There are many things already available. You don't have to reinvent the wheel. You just use the Spacey, for example, for NLTK tokenization and stuff. You can use Transformer for the already trained RAG models. You can even also use Transformer to use a Facebook open source model as a ChatGPT backend. That's how this whole process really work together. In next videos, we are going to discuss some more problems, which is synthetic data utilization. Nowadays, getting the data set is a very problem, and training the data set efficiently is a big problem here. How you can achieve this with the synthetic data set. There are some new methods coming in the market to do the addressing hallucination. By hallucination means that sometimes your ChatGPT model is giving you wrong response. How to improve that in the organizational commercial setting. And some customization or democratization means that how you can use open source models to create your domain specific. And then there is another big thing in the market, how you can get the benefit of cutting edge LLM and ChatGPT or AI on very small devices, for example, drones. You're flying the drone in the air and you want to make it intelligent. or robotic processes, or for example processes they are living on the edge device, a small processor, a microprocessor, how you can implement the AI on the microprocessor level. This is the next discussion within the community of the AI right now. We'll talk on that further, but stay tuned. Thank you very much. That's all today.